Okay, you can do your y equals x squared graph. Ought to be familiar to you. I've done it earlier, so I don't basic functions or tool functions. And the way I ask you to graph things, and that first section uses some other numbers here, but these numbers give you the shape of the x squared graph. And that's all that's really necessary to give you the shape of the x squared graph. Okay. So, the graph from -2 to 2, and of course from 0 to 4. Subdivide here from 0 to -2.5, we get -1. Subdivide that in half, we get 1/2. Here we get 1. Here we get 1/2. Here we get 2. And then I'm going to label it, there's 1. And halfway between 0 and 1.5. Halfway between 0 and 1/2 is a 4. You should totally understand that. Okay. Don't understand everything I just said. Go back to this part of the video, look at it until you do. Okay, make yourself notes, go out yourself, go out every day for a month. Think it through every day for a month, and it's just adequate. Then you understand this graph. And you need to understand, of course, the rules you use to get these numbers. Okay. But, okay, well, that gives you a point here and a point here. Here, point about here and here, here and here, and I'm going to do this and make sure. A fairly decent graph for the y equals x squared. Okay, so. You get the graph of y equals x minus 5 squared, you notice that this is the same as this if you just replace x by x minus 5. Right? Okay, so well, what you don't do is you don't make a table with these values of x and plug them into this thing. And you're going to get a graph that doesn't even look like a parabola. It won't even resemble a parabola unless you use some imagination. It'll resemble a part of a parabola, but you're not going to see parabola. You have to understand that there's a rule for this. You move all the points of the y equals x squared graph plus 5 units in the horizontal direction. There's a reason for that. Not the simplest reason to understand, but I'll tell you what it is in case you really want to know. In order to get the same y values here, x has to be 5 units bigger, doesn't it? Because you're subtracting 5 from x. If you want to get a value y that occurs in this graph, you're going to have to make x 5 units bigger. Okay? Now, you don't necessarily have to understand why that is. It's a little bit to think about. But if you want to understand, I recommend you think about it. Okay? Just want to follow the rules for now. Just to know the rules and follow them. For this course, that's all right. It's for calculus. I want you to understand it a little better. Okay? Because understand what you're doing there. I'll give you an example a little bit later. Idea for one of your toolkit functions, moving the function a little bit. It tells you exactly how bookies make odds. I don't recommend that you gamble. It's a losing proposition unless you know a whole lot of mathematics and how to transform even more complicated functions than you're going to see in your calculus. And know what all that means. And only about one person in 1,000 has the aptitude to really understand it. Okay? You don't have that aptitude, you don't belong in the gambling situation because you're going to lose. Well, now, if it's entertaining and you don't lose that much money, you know, like go to a casino with $20 in your pocket, no credit cards, spending $20 and have a good time. Okay? I still don't think it's a good idea. And most people don't have that discipline. They're going to be in there with credit cards and the deed to their farm and, you know, the way to sell their kids. If you don't have that kind of discipline, I don't think you ought to assume it. My point is, I'm not advocating gambling, I'm just telling you. And this has lessons for how we make decisions about other things. Because a lot of things we do aren't really gambles. Okay. You know, we're gambling on COVID by being here, aren't we? Okay. We reduce the gamble by wearing masks. And I appreciate y'all being so good about that. Yeah. I don't want to get it because it's going to disrupt my classes. It's my main reason. I haven't missed a class due to illness in 50 years. Okay. It'll be 50 years in May. I make it that way. Okay. So I don't get sick. But even a mild case of COVID disrupts things. If you get long COVID, you want me teaching this class at Grand Farm? I can barely find my way into the room right now. Okay. Well, my point is our gamble. Okay, I'm making a gamble here. Good math. Don't worry. It happens, it happens. Don't want you all to have in this class. Okay. They disrupt your room. Okay. The Omicron wave is winding down another 27%. But still a lot of spread in the community. So it's not time to relax just yet. It's like what people want to do, and I understand that. You know, do what you got to do. Okay. Those decisions are mathematical decisions. Decision of when to relax mask mandates is a mathematical decision. You got to have data. It's a mathematical decision. So that's an example. Of course, that's a little politically charged. People lose all common sense and do things for political reasons. Okay. And I'm people on both sides. You know. Some people want to keep the mask on longer than necessary, and it damages the economy more than it damages people. Okay. Some people want to relax the mask mandate, don't really even want to have them. And you know, don't really understand that. You know, going to make an issue of personal freedom. Take a better issue. There are plenty of issues that I pretty much agree with. Okay, I'm going again. Mathematics. Okay, business decisions and decisions that run economies are made mathematically in terms of functions that transform. And that's my whole point. I want to be in a soapbox about COVID. I'll come in my head. Everybody's up here with masks on. So I'll show you something about that. It's about the Bent-Vickers equation, which is the simplest possible transformation, almost the simplest possible transformation of the reciprocal function. 1 over x functions, 1 over x plus 1. Okay, well,
So again, the point is, it's important to understand the functions can transform. It's important to have a picture of what functions are, how they behave, and what you can do with them. So this is an important thing to understand. It's important to at least know the rule. Even better, understand why the rule is. Because X has to be 5 units bigger to give you the same thing. Okay, so what we do is we go ahead and do our graph of y equals x squared. Right now, once you learn how to sketch this graph and go through all the points, it's fairly easy to sketch a bad graph. Okay. Yeah, my vertex is over here. It should be the origin. Hard to get that right. Unless you're being really careful. It's okay. You can swap one down as long as you understand what it is and as long as it doesn't have curly cues and other stuff. Okay. So here it is. And now, got to move all these points to the right side. Which means I didn't draw it necessarily the best place because I'm going to have to move some of the points on top of my writing. But this means you take every point and you move it 5 units to the right. Now, how far is 5? Well, 2's here. So we can come out here. 4 would be about here. 6 would be about here. So 5 would be about here. Right? Now we take the origin and we move it 5 units to the right. And now we get a point on our graph. We take the point, let that represent point negative 1, 1, and this point 1, 1. And well, this point, 5 units. And this point here. And this point will move over 5 units. This point down here. And then these points will also move over. And we'll have a point here. And a point. So here's our graph. Without having to do any calculations, you just got to move things, know how to move. Now that just got this thing. Got all that on board. Okay. There it is. So this is a graph of y equals x squared here. And this is a graph of y equals x minus 5 squared. You don't get that graph by making a table, but let's just confirm that this really is the graph. Okay, if we do a table for x minus y squared, I'm going to do slightly abbreviated table. I'm not going to use 1/2, but that's important so you understand how the graph behaves as you get close to the origin. I don't always want to eliminate that one or and you know, I'm writing things down by reflex. So what I wrote down was right from what I wanted to write down. You see that I have points where x equals 3, 4, 5, 6, and 7. Okay. In other words, this graph is centered where the vertex goes. The vertex goes to 5. So the vertex is at 5. I'm going to put 5 in there, and then I'm going to put 3 and 4 on this side, and 6 and 7 on this side. If I want to do a complete table, I'll do 4 3/4 here and 5 1/4 here, which will correspond to the negative 1/2 and the 1/2. Add 5 to negative 1/2 to get 4. And I said 3/4, you get 4 1/2, right? And add 5 to 1/2 to get 5 1/2. Well, if I plug these into x minus 5 squared, if x is 3, 3 minus 5 is negative 2. So that's negative 2 squared, which is 4. And if x is 4, 4 minus 5 is negative 1, so we're squaring negative 1, right? If x is 5, we're squaring 5 minus 5, which is 0. And then we get 1 squared and 2 squared. That gives us 0.34. Which is exactly what we get if we take the point -2,4 and move it to the right 5 units. Gives us a 0.41, which is what we have here, okay? That's what we got when we took, well, we took this point and moved it 5 units to the right. So I can kind of draw these transformations. Not quite right on top of the other one. Okay. Well, there it is. And you can figure out the rest of it. Okay. So rules for transformations allow us to do these things. Let me digress and do the one I was going to tell you about. Okay. Now, I really don't understand gambling, how to make it work, because I'm not even interested. Okay. My brother, who got a birthday today, isn't interested. He makes money at it because he can read people like poker. Okay. He's in Las Vegas right now. In a house that he bought with his money. Okay. So he's a little younger than I am. Just a few years. He's still a young kid. Okay, well, so you know. He does things sensibly. He knows his limits. Okay, so anyhow, when he places bets, well, he doesn't place online bets and scoring. But sometimes he will bet just for entertainment, a little bit of on a sporting event. And he'll usually bet on the team he doesn't want to win. So no matter what happens, he's happy. He wins money, well, okay. He'd rather lose some money than have his team win. He's only done $5. Okay. So it's just it's a game. He doesn't go out and bet $5,000. Okay, so here it is. Okay. It's y equals 1 over x plus 1. Okay. How do you get the graph of y equals 1 over x plus 1? Okay. X is based on your odds, y is your likelihood of winning. How much you like to win. Okay. Or something like that. Not really care. So you got your 1 over x function, which looks like this. Okay. Now, if you replace, and you also have a part over here, but that's not relevant. So you, for the purposes of this model, you just restrict your domain so that all your y values are positive. Well, if we replace x by x plus 1, what's that going to do? That's going to shift the graph. Which way is it going to shift the graph? Well, x minus 5 required x to be bigger to give you the same values, right? So that shifted your graph to the right, which is counterintuitive. You see that minus and think it ought to go to the left. Unless you think it through or just remember the rule and say, I don't understand why it goes that way, but that's what it does. Okay? And that's okay. That's okay. That'll get you through a pre-calculus course, okay? For being an A student, you probably ought to try to understand. Okay, but not all A students don't understand. Anyway. And you know, might be C students that understand it, but just don't understand everything. So, not easy to understand, but not that hard. Okay. Anyhow, by the same rule, it's got to shift it to the left. The rule that you use, whether you knew it or not, I don't know how you did it without knowing it, that you used it, but people seem to have done pretty well on the homework, okay? Most people who did it. And most people in here did it. A couple of people aren't here. Okay, well, you do this. This means you take every point and shift it to the left 1 unit. Now here's one. Here's 1/2. Here's 2. And your values are 1, 1/2, and take these points, shift them 1 unit to the left. This point goes here. This point goes here. And of course, this point goes all the way over here. And now you have a broken piece of clock. If I can find that color. Purple. I want a purple. Ah, very good. Thank you. I thought I was going to have to use blue. Would have been okay. But let's keep it color-coded. Okay. So graph goes on something like this. Okay. Now I will use blue because this is a part of the graph. It's important. So you plug in the odds for X or something related to the odds, very closely related. And you get this, which is related to your probability of winning. Okay? So that's a big deal. Now, story. Yeah, this is a book I just got. It's 10 equations to rule the world. And so far, he's right on the money. First was on one we use in science. Sciences all the time. And I mean, the guy is a world-class mathematician. So. And he works with people in business, people in politics, people in one thing and another, consult with this guy a lot. He did the gambling thing. And what he found in the gambling situation was, and he bet like $1,000, okay? Which, yeah, he's got a good salary, can afford to bet $1,000 if he loses it. And he made small bets on the soccer tournament. I think it was the World Cup. He didn't care about the details. All he cared about was how the odds makers equation here corresponded with what happened in the real world with the real data. I won't understand how that's done. Then he said, okay, well, there's a little bit of a discrepancy. And if I can nail that discrepancy, I can cream money by placing a lot of bets, no big bets, just, 100 small bets. By replacing this equation by the equation 1 over 1 plus ax to the b. Well, this is an exponential function. With this function, and b is a small number and a is generally a small number, this distorts the shape of this graph a little bit in a way that's not hard to understand based on what you're learning in this course. So you could understand how this reshapes the graph. You wouldn't understand all the details of all the data analysis. You'd have to have much more mathematics. You'd have to have at least a degree in mathematics from a really good school. Okay, so you're not going to understand that. But you can understand this to an extent. And what he found was, he won a little money. And he then make bets with the money he had after winning. And he found that his money grew like the basic y equals 2 to the x exponential function, which is going to be really important in talking about. Okay? And if your money grows according to this curve, you will eventually, but not quickly, make a lot of money. Using similar strategies, and these guys who really do this professionally, seriously, at $100 million over a period of a few years. Okay. Starting with relatively small bets, $50,000 goes up to $100 million, worth 2,000 times what it started. Okay. In business, if you, there are many places in business where you make business decisions based on something very much like this, the likelihood of what's going to happen. You have enough data, you can figure out this number is, transform the function just using the simple rules that we know that we're trying to learn. Okay. You get all this stuff. Now I mentioned all this because here's an exponential function, here's another exponential function inside of this thing, and here's a transformation, simple transformation. Following the rules that you have to follow. Okay. And the exponential function you can understand by the rules you want to get in the mind. In this course, we'll probably see it sooner than that. In your pre-calculus course, just a little later. Okay. That's a plug for understanding the stuff that we're trying to learn in pre-calculus. There are many other applications. We're going to talk about some applications of quadratic functions. Okay, well, the other questions, wherever they are. Oh, there they are. Okay. Good time to digress there, but it's a good digression. This one, multiplying x squared by 2 means all the points move twice as far from the x-axis. All the y values are multiplied by 2. Okay, so again, you have your y equals x squared function. It's a little better with the word text. No problem with my hand blocks my view. I can't necessarily see where I'm going. If I do it backwards, I might have to try that. Okay, anyhow, this is y equals x squared. Okay, you take the points of this graph and you move them twice as far from the x-axis, because that doubles your y values, right? For this point, the y value is this. We double it. For this point, the y value is bigger. Well, doubling that, it moves us further. For this point, we go up, actually off the screen, but you get the idea from just a few points here. And that's not a screen, it's a blackboard. Okay, so, and the language your book uses is you politically stretch the graph. Let me call it that. Keep track of which graph is which. That's how vertical stretch works. And after we vertically stretch it, then we got to add another 3 to the y coordinate. Raises it up 3 units. Okay. And we'll do that. Yeah, we can use blue. And well, if this is here, then 3 is this much. So we move every point up 3 units. Okay, so 3 is this much. And we move this point up 3 units. We move this point up 3 units. And we move, let's see how far can we go. We can go up this point, we move this point up 3 units. Move 3 on the no, we move this point up 3 units. That's this point up 3 units, move this point up 3 units, and now we've got a graph. Every point is 3 units higher than this graph. Now that's not a stretch. That just takes This graph doesn't change its shape, it just moves it up. Right? So the first thing we did, we took our y equals x squared graph and we stretched it. It changed its shape because the points further from the x-axis had bigger y, are there because they have bigger y coordinates, so they have to move further. You can double the y coordinate. If the y coordinate is bigger, it moves further. Try to understand that. And then we have this purple graph, and then we get this blue graph, which is your y equals 2x squared plus 3. Okay, this parabola well, your y coordinate here would be 4. The y coordinate over here is -3, so -2 would be about here. 2 would be about here, so you have points there, here, and here. And here's your graph of the x squared function. Okay. Here's your y equals x squared. Well, your vertex is moved over 3 units to the left and 4 units higher, right? To move 3 units to the left, that's in the horizontal direction. So if we move this graph 3 units left, it's going to go here. And by the rule, at this point, this is a graph of y equals direction. So y equals x plus 3 quantity squared. Now you had problems of this nature. You would have hopefully followed this kind of reasoning, but sometimes you just imitate something because you don't totally understand what you're doing and you get the right answer. Well, doing that much in this preparatory course or this co-requisite course is a pretty good step, okay? You can try to go a little further because it's going to make your pre-calculus course much easier, but if you do that much, it's not bad, okay? So, anyhow, the purple graph is x plus 3 squared. And then you move this graph up 4 units. And you find that it coincides at this point and at this point and at this point, so that all of a sudden you match this graph. Okay. Now there's more that I could say, but I don't want to say too much. If you understand this much, you have a good start understanding the transformation you're going to do in your pre-calculus class. Okay. Okay, this is not too difficult to understand. Y measures how many we sell. We're selling. Usually we call them widgets. General term for something we sell. Okay. This is how many, whatever it is we're selling, how many we sell, and this is how much we charge. Now, I'm going to pause for a second to discuss this for a minute. Does that make sense? Okay, so this graph tells you that the more you charge, you do yourself. That's common sense, usually. Unless you're selling to status conscious people who want to pay more, so they say they pay more. Okay, there can be weird things in an actual, you know, how many we sell versus how much we charge. That's called demand versus price. Okay, so we call this demand. We call this price. And a lot of times the graph is kind of inverted for some reason, because business people have a weird way of thinking about things. At least that's the way it seems to somebody who thinks it's alternative science. Okay. Of course, they have the perception. And it doesn't really matter, but there it is. You want to understand this, okay? Okay, so that's how many we sell and how much we charge, okay? Now, we also have how much money we get, right? Versus how many we sell. What's that graph look like? You just gesture. Sorry, I'll pause for a second so you can say. If we do how much money we get against how much we sell, how many we sell, actually, the more we sell, the less we charge. So the less we multiply this number by to get this number. Okay? If the number we sell didn't matter, but the price didn't matter, we'd have just a straight function that went up like this. But since selling more means we charge less, because the less we charge, the more we sell. The graph curves like this. And I can prove this, but I'm not on it right now. You get a problem. Okay. Now, if this model holds, you see that eventually we're going to hit zero here. We're not going to sell any if we charge too much, right? Well, that corresponds to this point on the graph where we're charging so much that nobody buys. We don't take in any money. Over here, we're not charging anything. So no matter how many we sell, we don't make any money, right? So it's kind of an interesting graph. Well, this is revenue. Now, in an applied calculus course, which if you're like in business is probably the calculus course you're trying to prepare for in your pre-calculus course. This is called revenue, and you go through the details of the model. I'm not going to take you through the details of the model right now. Just going to tell you without proving it that you get that. Okay. If you factor the cost of producing these things, because it takes some money to produce things, okay, that changes the graph a little more. So if revenue is 2,000 minus 3x, And that would be like this function multiplied by the price you sell it for, which is X. That's how many you sell, that's how much you're charging, okay? Multiply how many you sell by how much you charge, minus $50X, which is how much it costs. It costs $50 to produce one, okay? That's how much it costs. Now, I just call this revenue, it's actually profit. The revenue would look like this. Your profit would add a cost function, which would skew this graph a little bit. Okay, and it would go through, still go through this point, but it would go through this point. That's good, that's straight. There it is. Okay, so the purpose of it. What should X be to maximize the profit? Okay. Well, first of all, if we expand this, we're going to get negative 3x squared here, right? You're going to want negative 3x times x is negative 3x squared. And then we're going to have plus 2,000x, right? But then we have minus 50x. It's a little more interesting. Let's say minus 500x. Okay, so we're going to have a 2,000x and a minus 500x. That's going to be plus 1,500x. And that's going to be it for this one. Okay. Now there might be a fixed cost on here, just another number. And let's go ahead and put another number on there. Let's say plus $100,000, but minus $100,000, because that's what it costs you to build a factory to produce this. Okay. So now we have minus 100,000. That puts a real damper in this because that lowers the graph. That's just the graph down 100,000, or it might look like this. Okay. Well, what are you trying to find? You're trying to find how many. Well, okay, let's change this a little bit, and I'm fudging a little bit. But let's say this is how much we charge. That's really the way the model gets set up. Because X is how much we charge, right? So there's our function. What we want is the coordinates of the vertex, because that tells us what price to charge, how much to charge, and it tells us how much money we're going to get, or how much profit in this case. Let me make this profit function and then get a little inconsistent. Okay, so we find the vertex. This parabola, because this is a quadratic function, recognized as an ax squared plus bx plus c, right? The form of this is ax squared plus bx plus c. What we did last time, the vertex, what's a quadratic formula tell you? It tells you where this is 0. And the negative b over 2a tells you where your axis of symmetry is, right? Okay. In this case, negative b over 2a. Well, what's b here? Well, b's 1500. B is your coefficient of x. A is your coefficient of x squared, right? Well, negative b over 2a is negative 1500 over negative 3, which equals 500. This tells you when x is 500, your profit is going to be maximized. Now I kind of got that spread out in a way that I didn't intend. So let's kind of summarize it. So you have P of x. For whatever reason, P of x is your profit function. Problems you have for homework on applications of quadratic functions. I'm going to just give you quadratic functions and ask you questions. Okay. So I've given you a little background about where this might come from. You don't have to understand that. P of x is your profit, x is your cost. Or selling price. And it's after simplification, negative 3x squared, 1500x minus 100,000. Now, in a minute, we're going to know whether we can make money on this. Now, it's always a gamble to set up a factory and produce something that we hope we're going to sell, right? And that goes back to the thing I talked about with the transformation of that gambling equation, which is a gamble. But it's not a gamble that's stacked against you. Okay? As it is if you bet on sports and stuff like that. It's a gamble. They go down to the casino, they're building 50 miles down the road, okay? This is a typical business gamble. You want to bring all the information you can into in order to make intelligent decisions and hopefully make money. Okay. So the graph of P of x versus x looks something like this. You can determine its zeros zeros are here and here. That is where the graph crosses the x-axis, which is where y is 0, right? We'll let y, say y is P of x, we talk about y. And the axis is symmetry. So we can find the vertex. You know the axis of symmetry, you just plug the x for your axis of symmetry into your function, it tells you what y is. Okay, well, a equals negative 3, b equals 1500, C equals negative 100,000. So your y equals p of x equals this, and off the screen. So let's do it now. Okay. There it is. Plugging into the quadratic formula. We get this. Okay. Over 2 times negative 3. Now, moment of truth here for your model. Since you have a negative in front of x squared, you know that the thing is upside down. So it has the shape, and of course you pretty much know that. Anyway, it's got to be that way, or otherwise it wouldn't be a reasonable model for this. Okay, this model. You better hope that you have zeros, because if you don't have zeros, remember when I asked you to sketch a couple of parabolas that don't touch the x-axis, means you're either above or you're below. Now, if you're upside down and you don't have zeros, that means everything's below the x-axis, which means y is always negative, which means you're always going to lose money because that's how much money you make. Okay? So you better have zeros so that what's under this radical sign, it darn well better be positive. Well, you got some pretty big numbers in here. Is this positive or not? Well, I'll do the negative 1,500 over negative 6, plus or minus the square root of, well, 1,500 squared is 2,225,225, 250,000. And this is negative. If this is too big, then we don't want to go into this business, okay? But turns out it's going to be okay because this is just 120 or 1,200,000. 12 times 100,000 negative, okay? Okay, well, 1,500 over 6 is 250. And this is $1,050,000. Okay, when we do the arithmetic, if I did it right, check me on it. So approximately, this is really close to 1 million, and the square root of 1 million is 1,000. And if you want to get technical, it's about 1,023 million. You can square that and see what it is. That's going to be 250 plus or minus approximately. That's going to be like 170. So that is 420 or 80. So the quadratic formula tells us where this function is 0. So we now know that this is at 80. So if we don't sell at least 80 of these, we're going to lose money, right? I mean, if we don't charge at least $80 for this thing, we're going to lose money because not enough people really want them to overcome the cost of producing and setting the factory up. here is X equals 420. If we charge $420 for these things, nobody's gonna- well, not enough people are going to buy it to justify our expenses. Okay. Now, our axis of symmetry is at negative b over 2a. Someone's already calculated that that's our 250. Right there's our negative b over 2a. Here's our negative b over 2a, comes out 250, which is right halfway between 80 and 420. Everything's nice and symmetric. The vertex is at 250, our x coordinate. That's how much we charge to maximize our profit. And to find our profit, we plug 250 into our P of X function, which gives you our Y value. So here's 250. Here's P of 250. And we calculate, we plug 250 in here. We see how much money we're going to make if we maximize our profit. Now, this is a prediction. Hopefully, we have good data to make our prediction on. It's a gamble, but it's based on hopefully solid mathematics and solid analysis of good sufficient data. Okay. Still a gamble. There it is. Okay, well, that's just one example. And typically, what you have to do for all of the functions, all of these questions in the assignment, and you'll see this in the examples and the explanations, is you're going to do the same analysis. You're going to figure out where the zeros are, you're going to figure out where the vertex is, and you're going to use that to answer the question. Now, of course, first you got to understand what the graph means. Okay, you don't have to understand the stuff that I explained over here at the level of why the graph, why the function is this. As I said, it's just going to give you the function. So all you got to do is figure out exactly what the quadratic formula tells you about that function, like we talked about last time. So, now, right now I've got two assignments, but I did get to talk about what you need for the second one. So there's only going to be one assignment due next Tuesday. Okay. I'm going to move that over so we can rearrange some of the assignments, give you time to do this. It's an important assignment because it really is your first real inkling of why this is an important course for you, and why the pre-calculus is an important course for you. Okay. And there's a lot of power involved in understanding the mathematics. It'd be very beneficial knowing what you do. And in the sciences, you know, the problems there are like business and science problems. For the most part. If I throw a ball, its path is gravel. I know how fast I threw it, know what the acceleration of gravity is, know what angle I started. I get a function. It has a graph. You can see how high that ball is going to go. So if you're a professional basketball player, you know the limits of how fast and at what angle you have to shoot it so you don't hit the ceiling. Okay. Well, they put the ceilings high enough, it's not practical to hit it anyway. If you shoot it in such a way that you hit the ceiling, you're probably going to have a disaster in your shot anyway. But you understand, when they design these things, you know, they use models. It's safe to put the ceilings at 20 feet. For high school, yeah, or special, I don't know. Okay. I could figure it out. But it's not hard to figure out if you know this model. Okay, well, very good. So try to do the best you can on this assignment, okay? It'll be beneficial to you.